see if this sounds familiar to you. So, like, I'm going to divide 4 into 618 by hand, like not with my calculator. Okay, so do you guys remember doing this? Like, you look at the first digit and you say, how many times does 4 go into 6? Does that sound familiar? Yes, no, maybe? Okay. Let me walk you through this if you don't remember. I hope you remember, because this is how you do it with polynomials. So if we can't do it with numbers, that's going to be a problem. Okay, I'm trying to think when COVID was, if maybe this would have been something you guys would have missed. So you look at the first digit. So I'm just looking at 4 and 6. How many times does 4 go into 6? 1 time. So then you put the 1 up here, and then do you remember what you do with it? We're gonna subtract in a second. You take the number on the top, you multiply it by the number outside. So I'm gonna do 1 times 4. You put that under that digit, and then you do subtract. So I just do 6 minus 4, which is 2. And then do you remember what the next step is? Okay, we could just bring down the next digit. Don't bring down both of them. Just bring down the 1. And then you repeat. So then I ask you, okay, how many times does 4 go into 21? 5. So then you put the 5 on the top, and then do 5 times 4 is 20. You write that underneath, and you subtract, and do 21 minus 20 is 1. Then you bring down the last digit. How many times does 4 go into 18? 4. So that goes up on the top. So then 4 times 4 is 16, and then we're going to subtract. Okay, now 4 is bigger than 2, right? So, we're not going to do decimals or anything like that, or fractions. So, what would you call 2 in that situation if 4 is bigger than 2?
Is it like the remainder?
Yes, the remainder. Okay, so here's how I would, this guy, 4 is bigger than 2, so this is what we call a remainder. I don't know why I need to write the word out. So, my answer would be 154, and I'm just going to have you guys use like the letter R to represent the remainder. There's other ways to do that, but that's just what I'm going to have you do. That's my answer. Okay, now, just to let you know what it means, if I were to take 4 times 154, I have a remainder. I would have to add 2 to that to get the original number that we had under the dividing sign. It just means it doesn't divide in evenly. And I'm going to make a bigger deal about this in a second with the polynomials, but because you have a remainder, 4 is not a factor of that 618. Anytime you have a remainder, if it doesn't divide in evenly, that means that number is not a factor of, in this case, we were dividing into 618. So 4 is not going to be a factor of that. So if you were to do it on your calculator, you have a decimal answer. And we're going to do it by hand with the polynomials, so we'll just leave it as the number 2 being our remainder. We're not going to mess around with decimals. Okay, so let me try one more. Now, if you have a 2-digit number, you do kind of the same thing. I'm going to divide 21 into 672. So, like, obviously 21 doesn't go into 6. So you scooch over to the 67. Can you guess how many times 21 would go into 67? 3 times. So you put the 3 on the top. 3 times 21 is going to give you 63, right? And you just subtract in between each of these steps. So 67 minus 63 is 4. And we have another digit here in the number, which is 2. So you just bring that down. How many times does 21 go into 42? 2. Now, 2 times 21 is actually 42, so then I don't have a remainder. My actual answer to the question would be 32. What it means is 21 times 32 is exactly equal to 672. And what it also means is both of those numbers, actually 21 and 32, are both factors, meaning it'll be dividing it evenly, of that 672. There's going to be a bunch of questions they'll say, like, is this a factor when we work with the polynomials in a second? And so the way you can tell is if there's a remainder, it's not a factor. If you don't have a remainder, like that one we just did, then it is a factor because it divides it evenly. Okay, now I'm not going to lie to you. This is not hard, but it's very weird. So I'm going to use my highlighters, but we're going to do the same process. It's just going to be with polynomials instead of plain numbers, and it works the same way. So you're just going to look at, most of the times the expressions will have a couple terms on the outside like they do here. I'm going to take x minus 5 and I'm going to divide that into x squared plus 2x minus 35. Okay, so what I'm going to do, I'm just going to highlight, almost like I would highlight the first digit if I was doing this with numbers. On the outside though, if you got a couple terms, you just look at the very first term, which is just an x. And what I'm going to ask you here, just look at the x. What would you multiply x by to turn it into x squared? X. Okay, so just what would you multiply on the outside to get this very first term on the inside? And you guys said x. So that would go on the top. Okay, now when you do the remember how we did like on the top you multiplied on the outside? We're going to do that. And in this case, you involve both of the terms on the outside. So x times x gives you x squared, which is what we want. We're going to try and cancel that out. And then x times negative 5 would be negative 5x. Okay, now this works just like regular long division. You're going to subtract between the steps. The really tricky part is the second piece of this. But if you did this correctly, this first term should always cancel out. X squared minus x squared is 0, right? That should go away. This is the part people mess up. And I literally like make myself like touch this with my pencil to remind myself. You are subtracting this. So I have to distribute that subtraction sign. So I have 2x, I'm just trying to combine like terms here, and I say to myself, okay, like minus a negative. I literally like make myself touch that. What do you do if you get minus a negative? You're adding. So if you get minus a negative, this is really going to be 2x plus 5x. So when I subtract that, because it's minus a negative, that's going to end up being 7x. Does that make sense? I know it's a little bit weird, but it's minus a negative. You have to distribute that subtraction sign. So if you get a negative and a negative, you're actually going to add that number. Okay, now what you do, like you do with a number, you're just going to bring down, instead of a digit, you bring down the next term in that polynomial there. So I'm going to bring down the negative 35. And then I'm just going to ask you one more question. Repeat that process. Just look at the very first thing outside here and the very first thing outside here. What would you multiply x by to turn it into 7x? 7. So then up here, we're just going to put plus 7. And maybe I'll try and be consistent and use the same marker. That was dumb. All right, 7 times x is 7x. 7 times negative 5 is negative 35. And I always just put that in parentheses because I have to subtract both pieces. In this case, both cancel. So 7x minus 7x, that's 0. Negative 35, I'm just showing this to you here, minus a negative 35 is really negative 35 plus 35, so that actually cancels out as well. So there's no remainder. Okay, your answer to the question is what we have on top of the lovely division sign, which is the x plus 7. That's the answer. What it means is if I were to take x minus 5 and x plus 7 and FOIL that out, it would give me back what I had under the division sign. That's what that means. What it also means, I'm just going to draw an arrow here. Both of those are factors of that lovely polynomial that we had under the division sign. Because both of them, if we would have had an x plus 7 on the outside, it would have also divided in evenly. So there was no remainder. It means both of those little sets of parentheses are factors of that lovely quadratic. I know this is weird. We're going to practice this again. All right, so come over here. You're just going to look at the first term on the outside. So I'm going to take 9x plus 2, divide that into this big long cubic 9x cubed minus 34x squared, blah, blah, blah. Okay, what would you multiply 9x by to turn it into 9x to the third? X squared. So you have a 9, you don't need a 9, right? You just need 2 more x's. So we're going to go x squared here. Okay, now the 2 that's out here with the 9x, now this is involved. So x squared times 9x should give me 9x to the third. That should match. That's what we're trying to do. We're trying to cancel that out. X squared times 2 would just be plus 2x squared. You can always multiply. Now, again, the super tricky part is going to be the second piece of subtraction. The first piece right here, 9x to the third minus 9x to the third should go. And I just make myself touch this subtraction sign. So I have negative 34 minus a positive. Now, minus a positive will be just subtraction because a negative times a positive is a negative. So this would be negative 34 just minus 2, right? Negative 34 minus 2, so we're going to get negative 36 x squared. And just like you would with a number, bring down the next digit, we just bring down the next term in the polynomial, which is that negative 53. And then I'm going to go through that process again. All right, so I'm going to ask you, we're just going to look at that 9x on the outside. What would you multiply 9x by to turn it into negative 36x squared? Negative 4x, good. So 9 to go to 36, you got to use a negative 4. And then x to go to x squared, I need another x. So then this negative 4x on the top, we're going to multiply by both guys on the outside. So negative 4x times 9x should match this, negative 36x squared. Negative 4 times 2 would be negative 8, and then we just have an x with that. And then just like normal long division, you're subtracting between the steps here. The first piece, that negative 36x squared, that should just go. This would be minus a negative, so it would add up to 0. I also have to be super careful just with that second term. So I got negative 53. Feel free to use a calculator if you want to, but it's negative 53 minus a negative 8. So it's really negative 53 plus 8, which would be, my brain's not functioning, negative 45x. And then I had one more term up there at the top to bring down, which is the negative 18. So this would be my last step. So I'm going to ask you one more question. Just look at that 9x outside the division sign in the original problem. Just look at the first term. What would you multiply 9x by to turn it into negative 45x? Negative 5, right? Just need a negative 5. I already got the x, so I just need to change the number. Negative 5 times 9x, negative 45x. Negative 5 times 2 is negative 10. And then I always just put that, what I got there, in parentheses because I need to subtract both pieces of that. Just be really mindful. The first piece should just go. The 45s are going to cancel. Now, the second part's the one that everybody can have a little bit of a rough time with. So I have negative 18 minus a negative 10. So it's really negative 18 plus 10, which is negative 8. Okay. Now, you're not multiplying 9x by anything to get negative 8, right? So just like a normal division problem, if it doesn't go in, then that's going to be your remainder. So my answer to the question, we'd have x squared minus 4x minus 5, and you can just write r for the remainder, and it's totally fine for that to be a negative number. That is my answer to the question. It could be, the remainder could be negative, it could be positive. It could also be an expression. I don't think I have any questions where it's an expression, but it can be positive or negative when you're working with the polynomials. And in this case, what this means, if I did 9x plus 2, and I multiplied that by what we got, the x squared minus 4x plus, or sorry, minus 5, I would have to subtract 8 from that answer to get, sorry, you guys don't have to rewrite all of this. You can probably see it in the example. But to get the original thing that I had under the division sign, I'd have to do like kind of like a super foil with that, if you will, foil on steroids, and then subtract 8 to make it result in what we had. So because I have a remainder, that is not a factor, and that's what this is going to ask you at the bottom of the page. How do you determine if one polynomial is a factor of another? If you have a remainder of any kind, it could be a number, positive, negative, it can be an expression, then it's not a factor. All right, if you have no remainder, like we did in that first example, then it is a factor. So if you have a remainder of any kind, positive number, negative number, expression, it doesn't divide in evenly, it's not a factor. If you don't have a remainder, then it will be a factor of the polynomial. So I'm going to ask you that in the next example. Does anybody have any question at the moment? Okay. So this is really just a yes or no question, but we're going to use long division to answer the question. It just says determine if x plus 4 is a factor of the polynomial. So if I want to see if it's a factor, I want to see if it divides in evenly. So I'm just going to set up, why didn't I hold the pencil here? Okay, I'm going to divide x plus 4 into that lovely polynomial. They give me x cubed plus 3x squared minus 6x minus 7. The answer is going to be yes or no. But basically, if I have a remainder, my answer is going to be no. If I don't have a remainder, my answer is going to be yes. So we're just going to practice this again. What would you multiply, just on the outside, just look at the x. What would you multiply x by to turn it into x to the third? Right, so I've got 1x here, so I need 2 more, so it'll be x squared. All right, so that goes on the top. Now the 4 on the outside is involved in the second step. So x squared times x, give you x cubed. X squared times 4 would give me plus 4x squared. And just please, please, please put that in parentheses because you have to subtract both of those pieces. The x to the third, but x cubed right there, both should cancel if you did it correctly. And then I have 3x squareds minus a positive. Minus a positive is just subtraction. So it's just 3 minus 4. So this would be just a negative 1 or just negative x squared. And then I'm just going to bring down that next digit. Next term in the polynomial. And I just asked you again. Okay, what would you multiply x by now to turn it into negative x squared? Can I multiply x by to turn it into negative x squared? What do you think? I need another x, right? It should be positive or negative. This is negative, so you gotta have negatives. So it's just minus x is what you're gonna put on the top. Sorry, that looks like that connected to my exponent there. Okay, now negative x times x is negative x squared. Negative x times 4 is negative 4x. And I always just put whatever I get as my result, put that in parentheses because you gotta distribute that subtraction sign. Now, negative x minus a negative is really plus, goes away. This is negative 6 minus a negative 4. So it's really negative 6 plus 4, which is going to be negative 2x. Now, you guys might be able to tell right now whether or not you're going to have a remainder. I'm just going to keep going a little bit to show you. But if I'm going to have a remainder, my answer to this question is going to be no. If I don't have a remainder, then the answer to this question is yes. What would you multiply x by to turn it into negative 2x? Negative 2. Okay, so negative 2, so we get negative 2x. Negative 2 times 4 is negative 8. Now, I can go ahead and go through and do the subtraction and everything. This will cancel, but I can tell right now those don't match, so I know I'm going to have a remainder, which in this case you'd have negative 7 minus a negative 8. The remainder would just be 1, but my answer to this question is no, because I end up with a remainder. I need that to be 0 for that to be a factor, so that does not divide in evenly. And if you can tell as you're going through, you don't have to keep going like I went all the way down to the end there. If you can tell, like, hey, I know this is not going to work out, you can stop and say no if you can tell you're going to have a remainder. Okay, now I'm going to try one more question with you. This is x plus 4. And this time I'm going to divide it into this 2x to the 4th plus 3x cubed minus 20x squared. Goodness, this has a lot of terms. Plus 7x plus 28. All right, so this one's into a quartic. What would you multiply x by to turn it into 2x to the 4th? 2x to the 3rd. Good. You got to have a 2 because I don't have anything in front of the x. And I need 3 more x's to take 1 up to 4. Okay, 2x to the 3rd times x should match up with this 2x to the 4th. That'll cancel that out. 2 times 4 here is 8. And then that'll have an x to the 3rd with it. Now, we are subtracting here. That first term should just go. You really just have to worry about the second term and just be careful, like, should I be adding or subtracting? So this is 3 minus a positive, which is really just 3 minus 8. So then this will be negative 5x to the 3rd. Bring down your lovely next term in the polynomial, which is that negative 20x squared. And then we're just going to rinse and repeat. Okay, what would you multiply x by to turn it into negative 5x to the 3rd? Oops, sorry, I'm breaking my lead off. negative 5x squared, right? I have one x. If I need to make it up to be 3, you need an exponent of 2. Add the exponents, and then I need that negative 5. So negative 5 times x is negative 5, sorry, negative 5x squared times x is negative 5x cubed. That should match. Negative 5 times 4 is negative 20, and then the x squared. Now, in this particular case, this goes and this goes. Both of those go. All right, so I don't have anything right now, but I still had some more terms in the polynomial. So all I would tell you to do, I'm just going to go ahead, since I don't have anything, I'm just going to bring down those last two terms. And that can happen. It just kind of depends on the question. I got to keep going, though, because I got to see if we're going to have a remainder or not. But in that case, all the terms canceled out right there. So I just brought down the rest of the polynomial. All right, now I'm going to ask you one more question. What would you multiply x by to turn it into 7x? Just need a 7. So that would go on the top. Now 7 times x is 7x. 7 times 4 is 28. We're going to subtract these. They match exactly. So I have no remainder here. So then my answer to this question, that is a factor because it divides in evenly with no remainder. I just tried to put some different situations in these problems today to show you guys kind of what can happen. Okay, now this next one is a little bit weird because it is missing powers of x. All the other questions we've done so far, if it had like an x cubed, it'd have an x squared and an x and everything else. This one is missing powers of x. Now, you don't have to do this, but I would recommend this. If you look at this lovely thing, I'm just going to rewrite it real quick. So I have x minus 2. And this will make more sense in a second, but I have an x to the 4th, right? And then I don't have x to the 3rd. So what I would just recommend, just in place of that, I'm going to put 0x to the 3rd. I'm really not adding anything because 0 times anything is 0, but this will help you if you have to do any of the subtraction with the place value. And then I had the negative 3x squared, and then again, I'm missing an x. So I'm going to put plus 0x. Which is really not adding anything. It's just going to help you line up the terms. And then I had negative 10. So that way, in standard form, I represent every power of x. It's literally just to help you line things up. All right, so let's go through one. I know we've done this like 4 times today. Hopefully it's making sense. What would you multiply x by to get x to the 4th? What can I multiply x by to turn it into x to the 4th power? We got to have x to the 3rd. So like we'd have 1 here, so I need 3 more. Okay, now here you're going to see exactly why I did this. So x to the 3rd times x is x to the 4th. X to the 3rd times negative 2 is negative 2x to the 3rd. And again, I just put that in parentheses so I don't forget to distribute that subtraction. And then that 0x cubed is literally just in there to help you with the subtraction between those two steps. These guys go. So I have 0. Right? Minus a negative 2, which would really be 0 plus 2. So this is going to turn into positive 2x cubed. I'm going to bring down the next lovely term in the polynomial, which is that negative 3x squared, and just rinse and repeat. What would you multiply x by to turn it into 2x to the 3rd? We don't need a negative because it's just 2, so just 2x squared. Good deal. All right, 2x squared, so times x. 2x cubed, 2x squared times negative 2 is negative 4x squared. And we're just going to be super careful. That first term will go. Second term's what you got to worry about. Negative 3 minus the negative 4 is really negative 3 plus 4. So this is going to just turn into an x squared. And I know we wrote this in, but this just to help me with the place value, I'm going to bring down that 0x. What would you multiply x by to turn it into x squared? Just need another x, so plus x. Okay, x times x, x squared. X times negative 2 is negative 2x. And then again, that's just, that 0x is just to help you with the place value with the subtraction. So if I have 0, and I make myself touch this, 0 minus a negative 2 is really 0 plus 2. So this is 2x. And I'm going to bring down that last term in the polynomial, which was negative 10. So just one more question for you. What do you multiply x by to turn it into 2x? What would I multiply x by to turn it into 2x? 2. just need a 2. We already got an x. All right, so 2 times x is 2x. 2 times negative 2 is negative 4. Now, this question did not ask me if it was a factor. It's just doing long division, so I'm going to keep going with this. This would be the 2x's go. All right, negative 10 minus a negative 4 is really negative 10 plus 4, so this would be negative 6. Sorry, I'm writing too big. All right, my answer would be what I got across the top, that x cubed plus 2x squared plus x plus 2, and then I did end up with a remainder of negative 6. I don't want you to always think you get a negative remainder, because that's not the case. But in this question and the one we did on the front, both of the remainders were negative. It could be a positive number or a negative number. And then we're going to do one more, and then I'm going to stop bothering you. Okay, now, one more time we're going to practice with this. I'm going to divide 3x plus 5. Oh my goodness, I cannot keep the lead in my pencil today. Into that 3x cubed minus 10x squared minus 67x minus 70. Feel free to use a calculator if you want to on any of these to do the division if you need some help with that, or any of the subtraction we're doing. But this says we're going to completely factor this. So I'm just going to start the process just like we did every other question. We're just going to take one extra step when we get done. What would you multiply 3x by to turn it into 3x to the third? What can I multiply 3x by to turn it into 3x to the third? Just x squared. You don't need a 3, you already got it, right? You just need a couple more x's. So x squared. X squared times 3x is 3x to the third. X squared times 5 would just be plus 5x squared. And then I'm just going to subtract. The first term always goes if you did it right. Now, I have negative 10 minus a positive, which is really just negative 10 minus 5. So that's going to be negative 15x squared. Bring down your next lovely term, which is the negative 67x, and rinse and repeat. What am I going to multiply 3x by to turn it into, what would you multiply 3 by to turn it into negative 15? 3 times what is negative 15? 5. Yeah, we need 5. Okay, so I just need negative 5, and I need one more x, right? Because this is x squared, this is x. So we're going to do negative 5x. Okay, negative 5x times 3x is negative 15x squared, and then I do involve that other 5 on the outside. Negative 5x times 5 would be, what, negative 25x. And again, feel free, if you want to grab your calculator. I, of course, don't have mine up here, so I'm trying to do this in my head. Okay, this is negative 67 minus a negative 25, which is really negative 67 plus 25, which would be negative 42. Thank you. Okay, I'm going to bring down that negative 70. Okay, now this does go in, so if you want to check, does anybody know what you would multiply 3 by to turn it into 42? It's 14, and I should have said negative 42, sorry, because that's a negative. So these both already have an x, so if you're not sure, take that number, divide it by 3, and then you can figure it out. This should be negative 14. Okay, negative 14 times 3 is negative 42, and that has an x with it. Negative 14 times 5, awesome, is negative 70. So that exactly matches, so when I subtract that from itself, everything cancels, there's no remainder. Now, the original question, if it says this to you, we're going to completely factor this. All right, so my original problem was what I have under the division sign, and I got 3x plus 5, x squared minus 5x minus 14. If it asks you to completely factor something, it's trying to tell you, like, whatever we got as our answer could be factored a little bit further. So I'm going to keep that 3x plus 5 they originally gave us to divide in. Can you guys, just for this quadratic, this little review from our last unit, can you think of two numbers, if you multiply them, you get negative 14, and you added those same two numbers, you get negative 5. Negative 7, positive 2. It doesn't matter which one comes first or second. I'm just going to write the x minus 7 and then the x plus 2. But this would then be that polynomial completely factored, which is ultimately where we're going to go with this to help solve some equations eventually, but we're just practicing the division today. Is anybody having a question?